record. Okay, yeah, look at the 2017 paper, guys. Starting off with question number 1 here. It's supposed to be A. Question 2, C. Question 3, A. Question 4, donkey, and question 5, C. Anyone here couldn't do any of these questions or need me to explain any one of these questions or not, guys? I repeat, question 1A, question 2C, question 3A, question 4, donkey, and question 5C. Anyone needs me to explain any of these questions here from the ABC part? Assuming everyone did it correct. Well, let's move on to the next part then. Okay. Look at this next part here. The first question, it says that figure 7.2 shows a plane mirror on a point object O and an observer's eye, point object O and also the observer's eye here. On figure 7.2, draw 2 ray diagrams from the object reflected to the observer's eye here. Now, like I mentioned, guys, there is obviously the easy way and there is obviously the hard way. I've told you guys to always cheat when they ask you to draw all these kind of mirror images. What you're expected to do is you're supposed to draw an arrow, right? Sorry, not draw an arrow, right? You're supposed to measure how far this distance is here, right? Let's say, for example, it's 5 cm. You're going to put this straight line exactly 5 cm away from the mirror, right? And then once you have the exact position already, you're supposed to say that this is the point of interest. And since you have the point of interest already, right, next thing you do is you draw all the light ray diagrams. Like I mentioned, real light is obviously going to bounce away from, it's going to be reflected by the mirror, right? And thus it's supposed to bounce away. It's supposed to look something like this, right? Once you have something like this, you're supposed to draw your straight lines here, your straight lines here. Wherever the 2 lines intersect, that is where your light ray is supposed to be. Probably it's going to be something like this. Let me draw here. Draw here on, probably a bit something like this, right? And you're going to dot, and then obviously you're going to get the correct answer from here. Yeah, guys, I highly recommend that all of you guys always cheat when you do these kind of questions here, because if you do not cheat, right, sometimes I have students they're telling me the image will be somewhere around here, which definitely doesn't make sense, right? Because if the object is here, by right, the image should be directly here already, right, guys? So whenever you talk about reflection of light ray, always do the cheating method. That's the easiest way to get your full marks here. And after that, on figure 7.2, complete your drawing to determine the position of the image of the object O. Label this eye here. So this is obviously going to be eye, right? And yeah, this is how you're supposed to draw the plane mirror, guys. Of course, you're supposed to use actual rulers and pencil to draw it. Then you'll have actual straight lines that will be easily drawn outwards here as well, but yeah, just attempt these kind of questions. It looks easy, but if you don't attempt it, you're definitely not going to know how to do it later on. Okay. Yeah, anyone couldn't draw this or anyone with any questions from this part here before I move to the next question? Hey, Kai-Hong, I recorded it for you already. If you really can't see, then you just watch it later on. Okay. Anyways, yeah, moving on to the next part here. Light is traveling in an optical fiber that is made of glass. The glass has a refractive index of 1.5. First and foremost, you identify this information. Explain why the quantity refractive index does not have a unit. Today, if you recall back, the formula is either going to be n equals to sine I over sine R, or it's going to be C over V. In terms of I over R, it will be degree over degree, which will cut each other off. In terms of C over V, it will be meters per second over meters per second, which yet again will cut each other off. So if you are asked to explain why there is no units for refractive index, you have to mention something like they have the same units and thus cancel off each other, or anything that the question is going to give, right? Since they have no units, signs have no units, signs are ratios, length of yeah, cancel off each other. Anything like, look at the mark scheme also is like super vague one, all right? Anything that has units canceling off each other. But of course, if I were to write down, I'll write something like the units are the same for both formulas. They cancel off each other. Something like that, right? To indicate that obviously you understand they have the same units and thus cancel off each other. Then after that, they ask you to calculate the speed of light in the glass there. Obviously, if the speed of light in glass, it's going to be n equals to c over v, whereas in the glass, v is equals to c over n, all right? So from here, it's going to be 3 times 10 to the power of 8 meters per second, divided by a refractive index of 1.5. Press that into your calculator, and you'll probably end up with something like 2 times 10 to the power of 8 meters per second. Right, you'll probably get something somewhere around 2 times 10 to the power of 8 meters per second here. Okay. Then finally, they ask you to describe one use of optical fiber in telecommunication. It could be anything, right? Telecommunication is mainly going to be the optical fibers for your internet that is used to transmit data. You know, like how I've mentioned last week or last week, I can't remember. Right, we mentioned about how the internet speed has increased from 1 kilobyte per second to 100 megabytes per second, or even 500 megabytes per second. All this is possible through optical fibers, which are transmitting data through light, speed of light, right? So if you look at this mark scheme here, it'll say something like information messages, send light travels along optic fiber, light is detected and message. Wow, all this nonsense. I don't know what the mark scheme is writing. I'll write something like one optical fiber in telecommunication. Optic fibers are used to transmit information online through online spelled on what online through used to transmit information online through the pulses of light with the application of total internal reflection. Yeah, optical fibers are used to transmit information online through pulses of light with the application of total internal reflection. Yeah, something along the lines. Let's copy this down here. Yeah. Anyone with any questions from this part here that you couldn't understand? Anyone can't do anything from this part here? Or needs me to repeat anything that they are uncertain of? Excellent. 100% absorption rate yet again. Then it's moving on to the next part here, which is obviously going to be the ABC chapter. Sorry, starting with ABC for 2019. The first 3 questions of the MCQ is supposed to be boy, boy, and boy for the 2018 paper, guys. The 2018 paper is supposed to be boy, boy, and boy. Before I move on to the next part here, anyone has any questions with regards to these questions here? Anyone got a different answer or need me to clarify anything from the ABC part? Okay, if there's no questions, then moving on to the next part here. This is a typical question in your IGCSEs. It is super common in your IGCSEs. Now, let me tell you what the students will usually do wrong for these kind of questions here. If you look at this question here, it says something like, Figure 5.2 shows a section of an optical fiber in air. A ray of light is incident on the fiber wall at X. So the ray of light at X here. Figure 5.2 continue the path of ray of light up to the end of the fiber here. Now, usually when the students, they see this kind of optical fiber questions, right? Because they kind of remember that it's supposed to use total internal reflection, right? So what the students, they'll do is they'll draw something like this, then they'll zigzag it all the way until the end here. Now, there is obviously two things wrong with this question here if you were to draw in zigzag motion. Number one, the law of reflection is not observed, right? If this is the normal here, you can clearly see that the incident angle is much, much, much more than the reflected angle here. So this is definitely not acceptable. And the second thing is, in order for total internal reflection to occur, it must be beyond the critical angle. As you can see here, this angle here is super large. Let's just say the critical angle is 40 degrees. This angle here clearly is more than 40 degrees, right? That's why I can go through total internal reflection. But if you draw in zigzag motion here, do you think this angle will be greater than the critical angle? Do you think that this angle here will be greater than the critical angle, and so on and so on and so on? So if you're asked to draw these kind of questions here, right, what I highly recommend you do is you don't draw the zigzag motion, and usually we'll draw, you know, if I were to draw this, I'll just draw at maximum 3 lines, 3 light rays probably. And depending on the scenario, it could possibly even be just 2 light rays, because yet again, if the law of reflection is correct, you know, like this angle here should be equal to this angle here. If it's not 100% equal, at least it should look the same in terms of eye level, guys. And in the maxim, I'm pretty sure they say something like that as well. One more reflection on top of the wall between X and Y. A 0 reflection on the lower wall of the fiber. The rays are supposed to reach the end. In fact, in this question here, you're not even supposed to reflect it, because this question here is prioritizing the law of reflection, guys. Don't ever draw zigzag motion. Most of the time, you will definitely be wrong for the zigzag motion. Okay, then after that, next part here, the refractive index of the material is 1.46. Calculate the critical angle. If they ask you to calculate the critical angle and give you the refractive index, obviously you're supposed to use the n equals to 1 over sine c formula. All right, then after that, c will be just shift sine 1 over n law. Press that into your calculator. You should be able to get somewhere around 43 degrees, guys. You're supposed to get somewhere around 43 degrees. It's just a matter of calculating, pressing everything in the calculator in the correct manner. It's supposed to be shift sign bracket 1 over 1.46. Then press equals, you should be able to get 43 degrees here. Okay. And after that, state 2 uses of optical fiber. Optical fiber could only be a few usage only, right? Telecommunication or endoscope only. In fact, I think that should be the answer. Yeah, telecommunication, endoscope, you know, specific audio display, specific lighting, carry, communication. Yeah, I don't know what the other is. I only know these 2 things, which is the most common answers. The most common answers in your IGCSE. The main usages of optical fibers will always be telecommunication to send data, and also endoscopy in medication. Okay, these are your standard answers and your standard questions here. As mentioned last week, guys. I think everyone should know this. If they don't, then it's GG. Okay, then after that, next part here. The critical angle for a type of glass is 42 degrees. Figure 6.2 and 6.3 shows 2 prisms ABC and PQR made of this type of glass. So if they are the same type of glass, they will have the same refractive index, guys. A ray of monochromatic red light passes into each of the prism here. State what is meant by, oh, you guys haven't learned this. You're supposed to learn this in the next chapter here. Something that we'll be going into once we are done with the lens chapter. It's supposed to be here, guys. If you do not know by now, let me tell you, monochromatic light. Monochromatic light, as the word mono suggests, mono means solo, right? Single, right? Chromatic means light lah. So monochromatic light is just single wavelength lights, guys. If they ask you this in your IGCSEs, you're supposed to mention that monochromatic light are light with single wavelength or single frequency. Don't worry if you can't answer this because you haven't learned this yet. I'll definitely go more in detail later on. But for now, just copy down this answer first. Yeah, light with single wavelength and blah, blah, blah. Okay. Then after that, the next part here, describe and explain what happens to the ray of light in figure 6.2 as it strikes AC, the prism here. AC, the prism here. You know, like just now they mentioned, right? The question already mentioned that the critical angle is 42 degrees, right? So if the critical angle is 42 degrees and here is clearly more than the critical angle, which is 45 degrees here, right? What's going to happen is total internal reflection is going to occur, right? Because the angle is already more than the critical angle. So you're supposed to describe and explain what happens. Your description is total internal reflection occurs. Explanation is because the incident angle is greater than the critical angle here. Okay, total internal reflection occurs. This is because the incident angle is greater than the critical angle. So greater than critical angle, and thus total internal reflection occurs. Okay. And finally, describe and explain what happens to the ray of light in figure 6.3 as it strikes the glass at point Y here. So at this point, what's going to happen? Refraction is going to occur along right at point Y. Why would they draw this thing here? Weird. This is 30 degrees, which is clearly less than the critical angle. That's why it's supposed to go through normal refraction. I don't know why this is here though. Let me see what the maximum says. Light refracts. Some light reflects backwards. Oh, okay. Some light reflects backward. I don't know why, but I guess it's just the way it goes. Okay. Yeah, actually, this is not supposed to occur, to my knowledge. Why is this thing? Okay, the first two parts is definitely going to happen since the incident angle is less than the critical angle. Most of the light goes through refraction and bends. Then after that, I genuinely don't know why some light reflects backwards though. Why will some light reflect backwards here? I'll check on this and then let you guys do again. But to my understanding, it's not supposed to go through reflection because maybe this is just normal reflection. This is total internal reflection. Anyways, I'll get back to you guys on this. I don't know why. I'll get back to you guys on this one. Let's copy this now. Since the angle is less than the critical angle, most of the light goes through refraction and bends away from the normal. Okay. Guys, any questions from these exercises here? Anyone needs me to clarify anything that they couldn't do from these exercises here? Good. 100% absorption rate yet again. Then finally, this last exercise that I sent you guys, check answers. Question 1C and question 2, boy. Anyone got these wrong and needs me to explain? Yeah, again, monochromatic light, you haven't learned it yet, but it's definitely going to be single frequency or single wavelength, guys. That's usually the definition of monochromatic light. Don't worry about it if you don't understand. We'll We'll go more into detail once we're done with this chapter. Okay. Then yet again, once you're done with that, this last question here. Yeah, figure 6.1. Figure 6.1 shows an empty container and an observer's eye. There is a small coin in position O. The observer is unable to see the coin. The observer and the coin stays in the same position and the container is filled with water. It's right now filled with water. The observer can now see the coin. Explain why the coin can be seen by the observer. So basically, when there is water filled in here, what's going to happen is light is going to go through refraction, right? And when light goes through refraction, we are the direction of the light wave kind of bends, right? And bends towards the object and thus enabling us to see the image, right? So if you look at the mark scheme here, it'll probably say the same thing as well. Light from water bends, and the refraction occurs. It's supposed to bend. Yeah, this mark scheme is super confusing right now. As water is filled, light no longer travels through refraction and thus like I mentioned just now, guys, without any water, the light is supposed to go straight, right? But right now with the water, because light goes through refraction, the observer is able to see the object because light has already bended towards the normal, basically, right? Yeah. Then next, state the name of the wave process which occurs as light passes from water into air. Obviously, yet again, this is going to be refraction. I don't know why this is here again. Stupid question. Explain why the image of the coin is a virtual image. Now, this is a very important question, guys. How come the image of the coin is considered a virtual image? It's because, guys, like I mentioned many times, light our brain perceives light to travel in a straight line, So what happens, right? Even though the light actually bended like this, our brain thinks that the light is traveling like this, It's like they kind of think that the light is traveling like this straight line here, and this is where the image is seen, guys. This is also the reason why you always stand on top of a swimming pool. It seems more shallow than it is, guys. It's because the light rays are supposedly bending, but our brain perceives light to travel in a straight line. So, explain why the image of the coin is going to be a virtual image. Light rays do not actually meet the image, only appears to come on the screen. Yeah, it's going to be a standard answer as well. I'm going to say that light has bended. Okay. And finally, they ask you to state the speed of light in air, which is obviously going to be 3 times 10 to the power of 8 meters per second here. After that, they say that refractive index is 1.3. Calculate the speed of light in the water. Yet again, you're supposed to use the N equals to C over V formula. V over C over N, and thus it's going to be 3 times 10 to the power of 8 over 1.3. Press that in your calculator, and you'll most probably end up somewhere around 2.3 times 10 to the power of 8 meters per second. Okay, everyone? Anyone don't understand anything that I've mentioned so far? Anyone needs me to clarify any of the questions? Good. 100% absorption rate again. Exactly what I like to see. Yeah, if there's no questions, then let's move on to the next part. Hey. Hey, I also want to clarify one thing, guys. You know, like how I've sent you guys the notes. How many of you guys have the chapters beyond the wave physics? How many of you guys do not have the notes for electricity and radiation? I think I need to get someone to send it to you guys soon already, guys, because I remember most of you guys only received the notes from general physics to thermal physics to wave physics only. Electricity physics should not be in your notes, guys. Can you guys check your notebooks right now and see how many of you guys have all the way until radiation physics? You guys know what I'm talking about? Yeah, most of you guys should have the notes until electromagnetic wave. Then everything else should be no more already. Meaning to say, this is supposed to be the second last chapter. How many of you guys have beyond? Sorry, let me repeat the question again. How many of you guys don't have the electricity chapter notes already? Because I remember most of you guys only receive until the wave chapter only. I need can you guys, yeah, for those who do not have more notes beyond the wave chapter, can you guys just send me a PM on WhatsApp later on? Then also send me your mailing address again. Then I'll get someone to send the notes directly to your place, guys. If you don't send it to me, I won't be sending anything to you guys. I genuinely cannot remember who has the notes and who doesn't have the notes, guys. So yeah, just send me a PM with your mailing address. I'll probably get someone to send it to you guys. The rest of the chapters, which is going to be electricity and radiation physics, to you guys tomorrow. Yeah, send me your address. For those who PM me, don't just tell me you don't have. Send me your address as well, because I probably lost your address by now already. So yeah. Okay. Anyways, yeah. Moving on to the next chapter here. Okay. Yeah. Hey, everyone, stop sending me messages. I can see quite a few of you guys are typing. Pay attention to this. It's gonna be a new chapter, guys. Basically, this chapter here, we're going to be covering the characteristics of a converging lens here. In your syllabus, there is no diverging lens. Means to say, if any of your school teachers are teaching this here, it is absolutely useless. You do not need to know anything about this except for the fact that it is there. There are two types of lens. One is a converging lens, one is a diverging lens here. Once you understand this, we'll also learn about the what's it called, labels of each and every one of the points of the lens here. You'll have to learn about the characteristics produced due to the lens Usually it will either be real, virtual, magnified, diminished, upright, or also inverted. When I say real, virtual, magnified, diminished, upright, or inverted, I mean the characteristics of the image produced, guys. Usually these are the applications of different types of lens. Depending on where you position your object, you'll see that this object is beyond 2f, this object is at 2f, this object is at in between 2f and f, this object is on f, and this object is in between the f and the optical center. Depending on where you position your object, you will definitely have a different characteristics of the image produced here. Don't worry too much about this. You definitely do not need to memorize this. You need to, however, understand how the light rays are going to work. I'll explain more about this later on, right? Then once you're done learning that as well, you're going to be drawing your own lenses here. You're going to be sending me your answers because this is very important. I need to make sure you know how to draw this. This is going to be 3 marks, guys. This lens chapter is definitely going to be 3 marks only if you understand how to draw all these kind of light rays here, which I'll be teaching later on. Then once we're done with that, we'll also learn about the dispersion of light, essentially how rainbows are formed, and we'll also learn about the definition of monochromatic light, which I've mentioned just now is either single wavelength or single frequency. Then it will be the end, and they'll be doing all your exercises here. Okay, so I think most of the Wesley students have already learned this. Yeah, I think most of you guys have already learned this. But anyways, yeah, this is basically a thin converging lens. Whenever we talk about lens here, lenses are basically used to redirect the light rays into the designated position. For example, the most common use of a converging lens is basically your glasses here. Now, in order to understand how glasses work, first and foremost, you have to understand how an eyeball works. You know, if I were to draw a super simplified version of an eyeball here, basically, if you have vision 20/20, meaning to say you have absolutely clear vision, when light rays enters your lens, it is actually supposed to converge at the back of your eyeball here, and this eyeball is basically going to be connected to nerves that are going to send information to your brain itself. Today, if you have long-sighted or you have short-sightedness, it basically means to say your lens is not as ideal as you want it to be, meaning to say your lens does not help your light ray converge into the proper position. If you have short-sightedness, probably your light rays are converging before the end of your eyeball here. If you have long-sightedness, which is low far to my understanding, is most probably because your light rays are converging towards the back of your eye here. By right, if your eyeballs has perfect vision, your lens is supposed to help the light ray converge into the exact back of your eye, but since you have short-sightedness or long-sightedness, your eyeballs are unable to converge the light to the back of your eye, and this is when the lens come into play. Right, today, if I have a proper correction lens here, what's going to happen is this lens is actually supposed to help converge all the not so good light rays to yet again to the back of your eye, and ultimately restoring your vision and helping you see clearly, you know. So basically, whenever I talk about lenses are just used for one thing only, to redirect the light rays to the proper designated position so that it can be seen properly, right? So, you know, if you look at the notes here, you can see that lenses are widely used in spectacles, cameras, projectors, and many other optical instruments. A lens can be thought of as a set of blocks and prisms. Basically, they help converge the light rays to the proper position that you want. Today, if the light rays are not converging in the proper position, you will be unable to see the proper image of the lens produced, or the image produced by the lens itself. Okay. Like I mentioned, in your syllabus, this is definitely not there anymore. If your teacher is teaching this, you can ignore everything you're saying, but you have to be very, 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 very well versed with the converging lens here. Okay. For converging lenses, parallel light rays are brought to focus at one specific point. Usually it will be at the back of your eye here, if these are glasses, right? So Yeah, before you even understand how the light rays are supposed to work, you're supposed to understand the very important labels of a converging lens here. Starting first with the optical center. Optical center is essentially the middle of the lens. That's why you see that this point here is going to be the middle. It will be exactly at the equilibrium positions here, guys. It will be exactly split it into half and half, and this is what we call the optical center. Okay, the optical center is essentially a place where the middle of the lens is, right? Then after that, the next thing you're going to learn is basically the principal axis. The principal axis is just a fancy term to say the x-axis of the lens here, right? Basically, this principal axis is exactly at the middle, which is at the x or x-axis coordinates, you know. Then after that, the next part here is known as the focal point. A focal point by definition is where all the light ray converges. A focal point here is supposed to be a point where all the light rays converge. And finally, the most important one, we call it the focal length. The focal length is essentially the distance. It is essentially the distance between the focal point and also the optical center. Now this here, although it sounds very dumb and very straightforward, I have seen countless times in many years of my teaching that the students are unable to identify where the focal length is. Sometimes, for some god-forsaken reason, they'll tell me that this is the focal length, or sometimes they'll tell me that this is the focal length, or even sometimes they'll tell me that, you know, this here could be the focal length, which I then answer with of course, first and foremost, a beating, right? If I see it in the center. And then I ask you guys again, guys, if you look at the definition of focal length, it's supposed to be the distance between C and F, right? If this is the optical center and if this is the focal point by right, this should be the distance, right? Not the damn distance from the optical center to the image, not the damn distance from the optical center to the object, definitely not the damn distance from the optical center to the screen. I beg you all, honestly speaking, please don't let me see any one of you guys draw unable to identify the focal length. By definition, the focal length is just the optical center to the focal point. I'll test you guys later on. Okay, so yeah, before I move on from this part here, anyone has any questions with regards to everything I've mentioned here so far? Excellent. 100% absorption rate as usual. Then once you understand the parts of all these lens here, the next thing you're supposed to understand is basically 6 major characteristics that is formed by the lens of the image, right? Usually the image could either be real or virtual. In your exams, if they ask you how to identify if the image is real or virtual, usually the answer is real images may be projected onto the screen, whereas virtual images cannot be projected on the screen. What do I mean? For example, today, this image here is considered real, right? For example, your camera or your eye or whatever, right? If today I were to put a screen here, the image will be projected on the screen exactly the same thing. Like, you know, like how cinemas, they project images onto the screen. Basically, I'm pretty sure they use either one of these here. Like, oh yeah, sorry, it's here. It's here, this one here, projector, right? The image can be reproduced in the screen. How else is an image not able to be produced on the screen? For example, your magnifying glasses. If you ever played with a magnifying glass before, you'll see that the image produced by the magnifying glass is super large, right? For example, you always see that the image is going to be here, right? This image is unable to be projected on the screen. Usually, we'll say that the image is real if it is formed by real light. You look at this here, this is formed by real light, this is formed by real light, this is formed by real light. We'll say that the image is virtual when it is formed by virtual light. As you can see here, this image is formed due to the convergence of virtual light, guys. Of course, in your exam, you cannot say real light or virtual light. You have to understand that by definition, real images can be projected on the screen and virtual images cannot be projected onto the screen, guys. So it's either real or virtual. Magnify or diminish is very straightforward. Magnify means to say enlarge, diminish means to say diminish become smaller right? For example, you see the object here initially was this tall, then after that the image produced is this small, then obviously the image produced is diminished right? For example, if here the object and here the object are same size, then it's going to be same size. If the object is smaller than the image, it means to say the image is magnified or enlarged. And same thing for this one as well, object and image here, you can clearly see that it is magnified, right? Now, of course, finally, the last thing will be upright or inverted, which is the most straightforward and dumb one today. Whether it is upright or inverted, you can see for yourself, right? Initially, the object is pointing up. Right now, the image is pointing down, obviously inverted. If the object is pointing up and the image is pointing down, inverted, up, down, inverted, up and up, then obviously upright here. Okay, so these are the 6 major characteristics formed by the image of the lens here. They will very commonly ask you questions on this here. So you have to be very well versed. You have to know when is it real, when is it virtual, when is it magnified, when is it diminished, when is it upright, and when is it inverted. Super straightforward, super easy. Usually the students will be able to get full marks from this part here. Then once you understand this part here, the next part is identifying how the light rays are going to behave in a lens diagram here. Today, in the lens diagram, usually, if you look at my notes that I've given you, I've given you like 1, 2, 3, 4, 5, and 6, right? Usually in your exams, they don't care about all 6. In fact, the first one is not important and the second last one is usually unimportant as well. The more important ones are going to be the second one, the third one, the fourth one, and also the last one here. Why are the first one and the second last one unimportant? Is because usually it's very hard for the examiners to test your understanding on this, because the images are not formed from the light rays. So I have in fact never seen any questions with regards to these two here. However, I have seen many questions with regards to this, with regards to this, regards to this, and also regards to this. And in fact, among all 4 of these that are relatively important, I would say that the magnifying glass one is the most important one, simply because your IGCSEs love to ask you guys about magnifying glass. You can double check this later on when you do the exercises here. I think out of the probably 4 or 5 questions, if they talk about lens, I think about 80% of them are going to be magnifying glass. So pay extra attention later on the magnifying glass. But before you even understand all these kind of things here, let's draw 2 simple light rays first, right? Usually in your exam, what they'll do is they'll give you the equilibrium position. Right, they'll give you the equilibrium position. Then after that, they'll give you a lens here. Then they will either give you the object or the image. Okay, if they give you the object or the image, let's say for example today they give you the object here, right? Then let's just say the focal point is here, okay. Then this is the optical center. Usually, if they say that this is the object, this is the focal point, and this is the optical center, they'll ask you to draw 2 light rays to find the location of the image. And if you ask to find the 2 light rays, it is a super standard procedure, guys. Pay attention to this. Usually, if they ask you to draw the 2 light rays, first things first is when you draw the first light ray, it's going to go directly straight. In fact, it should be parallel to the equilibrium position, right? Once you have this, the first line here, when it touches the normal, which is exactly the middle of the lens, you're going to draw the first light ray that cuts directly through to the focal point here. This is going to serve as your first light ray. Your second light ray is even more straightforward, starting from the same position, cut directly to the optical center. Wherever the 2 light rays meet, this is where your image will be formed. And usually if they ask this, right, they'll also ask you to characterize the images, right? Look at this here, obviously is diminished, right? Because big to small, right? Look at this here, obviously it is inverted law because it's pointing up and this is pointing down. And finally, it is definitely going to be real because the image is formed by real light. You can see that these solid lines here converge, right, to form this image. That's why the characteristic is going to be diminished, inverted, and also real. Usually, this is one of the standard questions that they'll ask in your IGCSEs. Very straightforward. I just have to remember it goes straight until the normal, cut through the focal point, then cut through the optical center, wherever the two light rays meet. This is where the image will be formed. This is the first scenario. The second scenario, which is also a super common one, which is going to be your magnifying glass. In terms of magnifying glass, usually, not usually, 100% of the time, your objects will be placed in between the optical center and also the focal point here. Okay, so let's say, for example, today my object is placed somewhere around here, right? Then they'll ask you to identify the location of the image, which yet again, you're going to draw the normal, which cuts through exactly the middle of the lens here. Then you're going to draw your light ray diagrams, right? You're going to draw a first light ray. Same thing also, I'll go straight, making sure that it is parallel with the equilibrium position here, right? Then after that, once it hits the normal, you're going to cut directly to the focal point. Second one is same thing as well. You're going to cut directly through the optical center. I mean, I'm not cutting it directly, but you get the idea, right? It's supposed to cut directly to the optical center. Once you have this, you will notice that your light rays are actually diverging, right? It will just go further and further and further away from each other. If your light rays are diverging further and further away from each other, what you have to do is you have to start drawing virtual light, which is represented by this dotted line here. Draw the virtual light in this dotted line here. Wherever the two light rays meet, this is where your image will be formed. Yet again, if they ask about the characteristics, it is definitely going to be magnified because it becomes bigger, right? It is definitely upright because it's pointing upwards. And it will definitely be virtual because it is formed by virtual light here, guys. Super important. You have to know how to draw these light rays because almost 80% of the questions is depending on you understanding how to draw the light rays. If lens chapter come out in your exam, you must tell yourself you should be scoring 100% for the lens question itself. So yeah, this is just a comparison. Straight line, focal point, cut through the optical center, image form. Same thing for this one as well. Straight line, focal point, optical center, converge it backwards, and this is where your image is formed. Okay. Yeah, anyone with any questions from this part here? Anyone don't know what I'm talking about so far? Okay, so yeah, this, I'm not going to elaborate much on these notes here. You can actually read through yourself. Today, the object will be infinitely far away. You actually don't even need to care about this. I just need to know where the object is placed, right? If it's super far away, your image will be produced here. This is the same application of the telescope. That's why you'll see that Mars is a very small ball in the lens of the telescope here. This one here, if it's a camera and the eye, by right, the object and the image should be inverted, right? These are your characteristics here, which I've mentioned just now. I'm not going to go through that again. Today, if you put an object exactly on 2F, this is essentially how the photocopiers make the same size images. It's because the object will be placed exactly on 2F and the image will be printed exactly on 2F here, thus making them the same size, guys. And this one here is just between 2F and F here. This is going to be for projectors and photograph enlargers. And finally, the most important one is going to be your magnifying glass. I emphasize again, your object should be placed in between the optical center and the focal point. Then this will actually produce a super large image at the back here. Usually, this is the application for the magnifying glass. Okay. If you were to memorize anyone, only just one, definitely memorize the magnifying glass because this one here comes up the most often, guys. Okay. Yeah, before we move on to the next part, anyone need me to clarify anything that we have mentioned so far? Okay, if you have no questions though, let's move on to drawing your own lens here. Yeah, if you look at this part here, right, I've given you guys at least 4 boxes. I can't remember if I revised it or not. But if there is 5 boxes, you're supposed to leave 1 box empty because most likely you're going to mess up one of the drawings. If you only have 4 boxes, be careful. You are expected to draw everything nicely. You see these 4 boxes here, right? What I want you to do is, right, I actually want you to draw the 4 images that are shown here, you know. It's going to be this one, and also this one here. The main difference between these 4 images is basically the position of the object, guys. Depending on where the position of the object is, you see this one here is beyond 2F, this one here is on 2F, this one here is between F and 2F, and this final one here is in between the focal point and the optical center. Depending on where you place the object, your image will be formed differently as well. So what I want you to do is, right, first and foremost, pay attention, guys. You're going to draw the skeletons of all the diagrams. What do I mean by the skeletons? First and foremost, you're going to use your ruler to draw a very straight equilibrium position here. Right. Then you're going to draw your lens exactly in the middle. It doesn't matter if it's thick or thin. The size of the lens is not important. You just have to make sure that the middle is going to be labeled as the optical center here. Then once you have the optical center, you're going to put your focal length to be 5 cm. Shit, was it 5 cm? It was 3 cm. Yeah, I think it's supposed to be 3 cm. Can't remember. So let's say you measure here 3 cm, right? You're going to draw your first focal point, F here. Same thing for here as well, 3 cm. You're going to draw your first focal point here. Then you're supposed to draw 2F as well, meaning to say here to here, another 3 cm. You're going to draw 2F here. Here to here, another 3 cm, and you're going to draw 2F here. Okay, 3 cm, all of it. It's going to be 3 cm, 3 cm, 3 cm. Then finally, you're going to be expected to draw the first diagram here. You see the first diagram is exactly behind 2F, right? Your first object should be placed exactly behind 2F. It doesn't matter how far you can cater it a little bit, but it must only be 1 cm tall, guys. Meaning to say, from the equilibrium position to the end of your object here, it can only be 1 cm tall. Once you have done this, draw the light ray diagrams and show me your first one first. Once you're done drawing the first one, I'll tell you what to do for your second one. Everyone, do this right now. Draw the skeletons and show me your light ray diagrams. Take a picture and send it to me. Oh, by the way, you don't have to draw the 3 cm things. You should have a final product that looks something like this. Making sure that here should be 3 cm away, here should be another 3 cm away, and your object should be somewhere around here. Then you should have F here again, and then yet again 2F here. Your final product should look something like this. I'm just leaving these scales here so that you know how to draw. Then draw your light ray diagram. Yeah, you're supposed to send it to me on WhatsApp. Okay, Payan, you have drawn the skeleton already right now. Draw the light ray diagram for and locate where the image is supposed to be. Because that 1 cm thing is supposed to be the object, right? Right now, you're supposed to draw the light ray diagrams that look something like this here and locate where the image is. Okay, good. Qingshan, yours looks nice already. Shanice one's looks correct as well. I think if you drew it correctly, you're supposed to have your image somewhere in between the second F and 2F here. If you have your image landing anywhere on the second F and 2F here, then most likely you are correct. Once, hey guys, pay attention now, since some of you guys have done the drawing correctly already, guys. The rest, you're supposed to draw up to 4 diagrams here, guys. All of it will have the same skeleton, right? In the sense that they are going to be 3 cm, 3 cm, and 3 cm away. Just that the position of the object is going to be different now. The first object, which you have already drawn, is supposed to be behind 2F. Your second object should be on 2F here. Your third object should be in between 2F and F. And your final object should be in between the focal point and the optical center, guys. Anyone don't understand what I'm talking about or not? You're basically supposed to draw these 4 diagrams here, but with my parameters instead only. Okay. So I repeat this again. Now you're supposed to draw. You already draw this one already. Next one you're supposed to draw on 2F. The next one you're supposed to draw in between 2F and F, and the final one you're supposed to draw in between the focal points, the focal point and the optical center. Okay. Yep, Yijen, yours is correct as well. Okay, so far everyone has been drawing the correct one, guys. Okay, for those who have already done the first one, draw the second, third, and fourth one, and then send it to me. Lian, your object looks much longer than 1 cm, by the way. Your height of your object should only be 1 cm, yeah? Yeah, but it's okay. This one is fine already. Do the next one. Wow. Wait, Shani, only drawing the skeleton only. You're supposed to end up with something like this. You drew the whole thing without taking the measurements. Wait, Shinan, do you take the measurements or not? Show me a drawing, Shinan. Yeah, you're supposed to follow the measurements like I mentioned here. The object is supposed to be 1 cm, it's supposed to 3 cm, 3 cm, 3 cm, 3 cm away. Agak it. You agak it, the whole drawing will probably not work out, I think. Of course not. Your exam is based on what the question is giving you. Right now, I'm giving you the parameters of 1 cm and 3 cm only. If the question, they say that the focal length should be 5 cm and the image is 2 cm tall, then you better draw 2 cm and 5 cm. But yeah, that's a good question. It's not a standard, it's just the parameters that I give you at this moment to draw into the box only. Okay, guys, you know what? I want you guys to finish drawing everything that is here, all right? And then for those who are unsure, you can always send me an image to cross-check your information of what you have drawn underneath here. We'll continue this next week, and then we'll probably be doing the exercises in classes next week together as well. Yeah. Yeah. I think I'm going to end class here right now because some of you guys are supposed to go for the other classes. Yeah, please draw, finish these 4 diagrams because I think it's very important that everyone knows how to do this, especially when it comes to the exam. It's going to be definitely 3 marks, but only if you know how to draw it. Okay. Yeah. For those who have no questions, that will be it for today. If you have any questions, you're always welcome to stay back, and I can always check your drawings here. Oh, good, Payan. Your drawings are all correct already. Shin-en, yours is definitely wrong. Okay, yeah, for those who want to go, you can go already. Oh my God. Hi, girls. Oh, okay. Bye-bye. Yeah, just draw everything if you want to. Yeah, then make sure you follow the parameters. Okay, see ya. Okay, let's go. I'm hungry.你有没有去问律师什么？我不懂，我跟你 share 一个就好了，我不饿。我想吃 pepper lunch， 你就有去 pepper lunch。啊？我想吃 pepper lunch。没有开，我那个东西关掉了，不是？我的吗？那个也讲，有时候啊。